And welcome everybody to our webinar for electronic ISOs. My name is Eleni Stark and I will moderate the webinar today. We are very pleased that you took the time to participate in our webinar. Our speaker today is our field application engineer Praveen Kartikeyan. He will hold today's webinar on the topic REDEXPERT, component selection and performance simulation made easy, and he will also answer your questions after the webinar. Before we start the webinar, I would like to point out one thing. You will be muted during the webinar today. This means that you can't ask us questions via microphone during the webinar. Nevertheless, you have always the opportunity to ask us questions during the webinar at any time via the chat function. You'll find the chat function in the webinar control panel. The webinar will be about 30 minutes long. The chat questions will then be answered in a question-answer session following the webinar. There are 15 minutes in addition scheduled for this. If we are unable to answer all your questions within these 15 minutes, please email us at isos-webinar@we-online.com. We will try to answer all your questions promptly. At the end of the webinar, you will be asked to participate in a feedback survey. We would be pleased if you take the time to fill out the survey and help us to optimize our webinars. The link to the recording of today's webinar as well as the presentation will be sent to you in a separate email 1 or 2 days after the webinar. You can also watch the recording of today's webinar 2 days later on our website under the navigation point Webinars or on our Würth Elektronik YouTube channel. Now I'm giving directly to our speaker Praveen Kartikeyan, and I wish you an exciting webinar.
Hello everyone, I'm Praveen Kartikeyan. I'm an FAE from India. Today I'm going to present a topic that is one of our tools which we recently have been promoting this a lot, and we have a lot of information related to components in this. This is called as REDEXPERT. This is one of our tools which will help a lot of customers and design engineers to select components. So today's agenda is split it into 3 different modules. One is general information. Here you will get a lot of information about the tool, the web page, and different attributes in this web page, and different charts, different product groups, and the benefits of using this tool. The second section, you will see how registrations and logins can be done. And I will also show you one example of a module. Of course, this REDEXPERT tool will have a lot of different modules in it. So we will take one example from this particular web page, and we will talk about that module. So basically, what is REDEXPERT? The recent slogan for this web page is select, compare, and simulate. This means this tool will enable a user, this might be a design engineer or a component engineer and a test engineer who wants to select some EMC components for his application. This will help you to select components. It helps you to compare different kinds of components in the same group, and also you can keep on simulating an application and find some optimum components for different applications. So this is an online platform. So earlier we had our tool called as component selector, where the updates were pretty cumbersome because it's an offline tool and a lot of users needed IT permission to install them. But now, since it is a live tool, all updates are live, and a customer just needs a computer and internet just to log in to this tool and simulate and select components. So the component selection is very easy, and the comparison of different components is easier with this tool. So there are a lot of design tools that are integrated to this web page. So if you want to simulate and find out some EMC components for your application, or if you want to see and select an inductor for different converter topologies like buck boost or SEPEC converters, you can do so from this tool. Of course, last but not least, the sharing of the results is one of key highlights of this web page. So you can, once the simulation is done, you can share this particular simulations to your colleagues or to Würth Elektronik representatives to also save it in your logs for future references. All these can be possible. So let me take you to the start screen of this particular tool. So this is how the home page of the REDEXPERT will look like. You can see products tab where all the different modules are listed here, and you also see applications where you can also specifically go to an application and simulate components for your requirements. Also, if someone is looking for just selecting components and they wanted to do it fast, so you also can go into the fast and easy component selection area and click on this, where you can easily get the components shortlisted. So this will only be more fair if I take you directly to the web page and show you how the web page looks like, and also we can see some attribute of this web page. So now you're seeing the web page. I have taken you live into this tool. So here, if you go to products, you can see EMC components and different component groups inside this are listed here. You have power products, you have signal products, signals and communication, you have capacitors, and you also have optoelectronics. So all these are listed in product groups. If you go into applications, you can also see a lot of applications like filter circuits. If you want to select a ferrite for your PCB, or if you want to select a ferrite for cables, or maybe a DC-DC converter, you can do so. Selection of inductors for different topologies, or maybe PFC chokes, or wireless power transmitting circuitry. Würth Elektronik also do WPCC coils, so you can also use this tool to build the resonance circuit for this application. And of course, this website has some videos here. This will help you to get started, and also use the charts and noise attenuation tools, how you can use all these things. There are short videos here. And of course, if someone wants to just go and select components easily, this has different components grouped so that it's easy for a component engineer to come and select components of his requirement. So now back to the presentation. So let me go into one of the user interfaces to give you a better idea how the page looks like. So this is the user interface page of one of the modules, power inductors, which I'm going to focus today. If we have to do all the different modules, this is going to take a lot of time than a short webinar. So, but this time we will focus more on power inductors. So I took the user interface page of this power inductor module. So you see the product table here on the top. This is nothing but where all the power inductor components are listed. On the right top side, you can also see, after you integrate one and the other filters, how many components are listed. So for example, here we have shortlisted one product series called MAPI, and the shortlisted filter is shown here. So in MAPI, this means we have 111 components listed. So like that, once in every time you use some filters, let's say if you're filtering inductance value, or if you're filtering rated current of an inductor, so based on that, the numbers goes down, so showing you how many components are left after you have filtered. So this is all about the product table. If you go into the product tray, this is where you can drag drop any component of your interest for selection and comparison. So for example, here we have selected 3 components. So all these three components can be selected by just clicking here, highlighting the tick mark, or you can just drag this component, drop it here. And then you can also see some charts in the bottom. So these charts are different for different component module. Now here in the power inductors module, you have three charts. One is the inductance versus DC current. X-axis you have the DC current, and if you move along the component marker, you can see the inductance value for different currents. You can compare them. Similarly, you can also use this chart to understand the temperature rise of an inductor with respect to DC current. And in all these options, you have the possibility to fix an ambient temperature of your application. So here you can see the inductance drop over current. So you can see how much inductance drop of different inductors which you are selecting will be there for different currents. Very importantly, you have design tools here. So for inductors, you can use these converter topologies to simulate a perfect inductor for buck, boost, or SEPIC applications. These are most commonly used applications worldwide. So we will also see in the coming slides how these can be used. One important attribute of this web page is the sharing option. So you can go into this web page, do all your simulations, and then you can share this particular page with your colleague. And some of my customers surprisingly use this application, use this share to send it to their managers to get approval of their design. And also in some cases, customer sends us back this link to show us their selection and request for samples. So you can use the sharing option. Once you go here, you will also get a short link, URL link of your simulations. You can store this particular link for your future reference, or you can share it with anybody. So let us take a deeper look into the UI page. So in the UI page, I showed you the product table, I showed you product tray, etc. So let us take a focused look at these areas in the UI. So this is the inductors product table. So here, as I said, you can use different filters by just clicking on the drop down button on every column. If you want to select an inductor based on its type, or inductance value, or rated current, DC resistance of the inductor, or the inductance value at a particular current. So you can sort or filter each column by using these tabs. You can just double click on any column to sort it as you like. So product tray, this is where you can drag drop your components which you are shortlisting and compare them. So here you just can drag and drop the components or select the tick mark beside the column. So once the component comes here, you can also keep on adding your filters. So for example, you have selected 5 components, and you have selected these 5 components by integrating 2 or 3 filters. When you add one more filter, and if one of these components doesn't falls under your filter, the component will go gray. The black text here, the part number, will become gray. This means after the recent addition of the filter, this component has become void, or it is deselected. And also, every selected part from the list, you will be selecting one part to see all the parameters like AC losses, DC losses, or temperature rise of the component. So when you have that part, the selected part, it will always be marked in red. So if you see here, this is the selected part where I have where the tool has marked it red. So the same part will also be marked in red here, and red here in the chart, and also it is marked red here. All the other selected parts will be color coded in different colors. So here you have amber. Similarly, the same component is listed here in amber and amber here. So like that, all parts are color coded, so it's easy for you to understand which one is what. So using the charts, so what are the different attributes you have in charts? So you can zoom in any charts by just clicking on the maximize to have a full screen view to see the charts in a very good size. You can also export these charts for your future reference. You can convert them into JPEG or PDF and store it in your system. Also, you can move your cursor along these charts to see for a particular current the values of inductance. So I move the cursor here, I can place it on a particular current value and see the inductance. Also, I can use the chart reader here and click here and drag this up and place it anywhere I want. We can also place multiple chart readers in the system. So we can add maximum of 5 chart readers in a single graph, where you have to read different current ranges and see the inductance value at that particular current. Apart from that, you can also show the selected marker values in the table. So when you click on here, you will see a table which shows different markers. You can also filter out vertical axis. This means when I put a chart reader and I want to narrow down the inductance value, so I want to fix a minimum inductance value and a maximum inductance value. So this also is possible. I just click on this symbol and I can filter it out. If I want to remove one marker, I can click here. So as I said, I can click on this and I can move this symbol and I can fix the inductance value so that further filtering of components is possible. On the other hand, you can also do this from the product table. You can go to the product table. You will have an additional column after you integrated the chart reader. You will have an additional table that says inductance value at the particular current, this particular current 1.4 amps. So you get it here. So here you can also add the set max and set minimum. So in the chart, when you want to compare a few components, you might have selected many components, and when you are narrow downing your search, maybe you need a comparison of only 2 components or 3 components. You can click on any components that you want to hide. Just by a click, the component gets hidden, and again you re-click it, it'll appear. Export option. So you go to this drop down list of every chart. You will have this on the right top corner of every chart. You can see export as image, export as PDF or SVG. You can export it as you like for your future reference and save it in your design logs for future reference. So there ends the first module, the basic information about the tool. Now we can also see some steps for the registrations and logins. So if you are a first time user, then probably it's important for you to know what are the benefits of a registered user. So usually a registered user gets a lot of perks for this website. So you can compare up to 16 products. That means you can add up to 16 products in your product tray and compare them. You can enable more simulation tools, like for the inductor module, you can enable the manual loss calculations tool when you are a registered user, and also you can add 5 chart markers, as I explained to you before. This is only possible for a registered user. And AC and DC losses, total losses, temperature rise, all these are extra parameters that one can see when they are a registered user. So if at all a particular attribute is only for it has a limited access and it is only available for a registered user, you will get a pop-in saying this feature is available only to registered user. So how do I sign in? So you can, on the main page, you can see a sign in button on the right top corner. You can click there. It takes you to the sign in page. When you're a first time user, you click on sign up. And this is going to ask you some basic questions about your email address, the password that you are going to use, your name, company details, some basic information for you to create a registration. You click on register. So you will get an email for double confirmation to your registered email address. So you click on this link and now you are registered. So the link will take you to the REDEXPERT login page. So here you click on REDEXPERT. From the same user account, you can also in the future go and look at the Würth Elektronik's Midcom's smart transformer selection. So once this is done, your name will appear on the place where sign in was there. So now this means you are a registered user and you've already logged in. So from the next time, you don't have to sign up. You just have to enter your email address and the password which you used for registration and directly get into the tool. So now we have seen how registrations is possible to this web page. We have also seen the basic information about the tool. Now it's time to take you to one particular module which I would like to focus today, which is power inductors. So we have a lot of modules in it. So maybe in the future webinars we will cover other modules. Now probably we will talk only about power inductor module. So this is the UI page which I showed you already in the previous part of the presentation. So here, without any filters, this tool have about 2500 components here, and you have the converter topologies on the left side. So you can use this to select a particular topology and find a suitable inductor for that particular topology. So this is how the tool will look like. When you click buck converter, you get this page. You click on SEPIC, you get this. You click on manual loss calculation, you get this. So this will ask you for some basic converter information like input voltage of the converter, output voltage, the output current, switching frequency, the ripple, allowable ripple in the inductor, and the forward voltage of the diode which is used in the system. So when you give all these basic information and you get the results of the simulation, this means you have all the input parameters here which you have entered, and then some details about the IRMS current of the inductor and the maximum current which takes the ripple current also into account, and the optimum value of the inductance the tool is recommending you. Of course, when you say 7.54 microhenry, you would have to go for a ballpark figure. So you would have to go for, let's say, 10 or 20% closer to this value. So this is also possible. And the tool calculates and shows you the T-on time of this topology and the duty cycle, the inductance, the inductor's current, the inductor's ripple current, and the peak current. Also here you can see the waveform, current waveform of the particular inductor which you have selected. And here the complete loss model is shown, the AC losses for this particular inductor, for this input parameters you have given. What is the AC loss model, what is the DC losses, both put together the total losses, and the temperature rise in the inductor for this application. You can also see here some graphs of power dissipations for different range of voltage inputs which you have given here, and the switching frequency. If you change the switching frequency here and there, what is the power dissipation for it, and the output current. So how this is more accurate? So we have this campaign for REDEXPERT that says world's most accurate AC loss model. So how this is accurate is because this model, the Würth Electronics model, considers both DC losses and AC losses. Of course, the windings will have both the DC resistance losses that is created by the wire, the copper wire, and also the AC losses, which is created by skin effects and proximity effects. So this is also taken into account when Würth Electronics create an AC loss model. And of course, the core losses, which is by hysteresis and eddy current losses. So all these losses put together is what we calculate as total loss of the inductor. Mostly the models that are in the market uses Steinmetz model, which uses sine wave generator as its input. So this means this is not evaluating a square pulse, and also this has limitations over different relative permeability, which we'll be seeing in the coming slides. But as far as Würth model is concerned, we use class D amplifier model just to calculate P in and P out very close to the inductor. So some advantages of the Würth's loss model. So this is a real-time application setup. So this is measured for every different inductor. So an inductor with different construction, an inductor with different let's say materials, or an inductor with different shapes and sizes will be calculated differently. A pulsating input is input voltage is given to this, so this is not using a sine wave model, and input and output power is measured very close to the inductor. And of course these empirical data are measured and used as an equation that runs behind Würth's model. And the advantage here is the calculation is very accurate for a wide range of duty cycles and over a wide range of frequency. So as I explained you, this is taking the point of operations approach. So this takes in account the triangular current waveform, wherein in Steinmetz model it takes a major loop. That means a sine wave excitation is used to measure all these AC loss models in Steinmetz. And also the accuracy is acceptable in Würth's model from a duty cycle of 0.1 to 0.9. So this is a broad accuracy range, but wherein the Steinmetz model will be more acceptable accurate level only at 0.5 duty cycle. So Würth model also considers different core materials like nickel zinc or manganese zinc. Also it considers different alloys of magnetic materials like metal alloys or iron powder, but wherein the existing Steinmetz model only measures a single material, mainly manganese zinc and nickel zinc, and this is not much applicable for iron powder and metal alloys. Of course, our model considers real core shapes, so different shapes of inductors, THT inductor or toroidal inductor or a radial inductor. Our model, we write different algorithms behind it and equations to find out the AC loss model for different shapes and structures. But here this only considers a toroidal core, that too without an air gap. So the fringing effect is also considered in the Würth model. The air gaps are also considered to define the loss model. So today we only focus on power inductors, but I would like to show a couple of slides about PCB ferrites. Maybe we can cover how PCB ferrites can be selected through REDEXPERT in a different webinar topic, but just quickly an overview of how you can select PCB ferrites. So here you go to the Ferrites for PCB assembly module, you click on that, you get the UI page of PCB ferrites. So now similarly how you had buck, boost and SEPIC, here you have two tabs, system and pulse. So when you click on the system tool, you can select the impedance of a ferrite for different applications. So you click that, you can select the source impedance of your application where you're going to use this ferrite. If you're going to use the ferrite in ground plane or power supplies or data lines or long data lines. So based on that, you can use the application hints, or you can set your own values here. Also enter how much attenuation you need and what is the targeted frequency. And also this is one of its kind tool where you can also incorporate the DC bias effect of ferrites. Many tools do not calculate the results of the ferrite value based on the DC bias effect. So when you say OK, you will see the input values that you have entered here and the required impedance value of a ferrite, which the tool recommends you, which is 99 ohms for this application. And also for this impedance and for this source impedance, how much is going to be the attenuation on the targeted frequency. So all these information will be available defined by the tool. And the same information you can also see it in the graph. You can also incorporate the chart markers like how you did it in inductors. There is one more option called as pulse tool, where you can also select a ferrite which can handle more pulse currents. So here you can select what is the peak current of the pulse. You can also select the length of the pulse, the time duration. You can also see the repetitive pulse, how many repetitive pulse you needed in your application. You can enter that. You can also enter what is your continuous current. So based on these 4 information, the tool is going to calculate and give you what and all ferrites you can use for this particular application. Similarly, you can see some extensive graphs here. So this will help you to understand the maximum pulse current versus pulse length. So you can fix a pulse time period and you can see how much maximum current a particular component can handle. Also the repetitive number of pulses for a particular peak pulse current. So of course I do not spend more time on the PCB ferrites. We will find another opportunity in a different webinar sessions to elaborate on the PCB ferrites. As such, please log into this REDEXPERT tool, and this will really help you to select, compare and simulate components. So it's time to answer some questions now. I have a question from a participant to show some example of the calculation of buck converters from the website. Of course, we can go to this web page and do some calculations from the web page. So I go to products, I go to applications, I go to inductors for buck converter. So there we have the buck converter page. So I'm going to give some inputs, some random inputs in mind. So I have 12 volts minimum, I have 15 volts and maximum 17 volts. An output of, let's say, 12 volts. Okay, then for that I have to increase this. Yeah, and 1 amp current. Let's say 750 kilohertz switching frequency. An allowable ripple is lesser, so I will consider 30%. So of course the allowable ripple is inversely proportional to the inductance value. So if we reduce this, then probably the value of inductance that we are going to calculate will be more. So I give all these inputs, I click on display details, yes. So the tool calculates the inductance value, the optimum inductance value is 10.7 microhenry. So this, using this information, the tool has already added some filters in the tool. So the inductor type has been selected. So the type of the inductor is single and the rated current more than 1 amp, and saturation current is more than 1.15 amps, and the inductance value range. So the tool has added some range of inductance value. So with this, you can see that we have shortlisted from 2500 inductors to 172 inductors. So 172 is also a big list. So now I go here and then select the DC resistance. So I need less DC resistance for my application. I say all components 100, less than 100 milliohms I need to select. So I reduced the list from 170 odd to 140 odd now. I also want less losses, so I go to total loss and say maximum I can handle 75 milliwatts. So I'm first shortlisting the list to 98 components. The next crucial for the design engineer is the height and the area of the component. So I go and say I need a component that is less than 3.2 mm, which is very critical for me for my application. So I have 4 components here. So I have shortlisted from 2500 components to 4 components. And from here you can also select whether you need a shielded inductor or non-shielded inductor, and what kind of material, whether it's a nickel zinc core material or manganese zinc and nickel zinc alloy. Or you can also select whether you need a SMD surface mount component or a through hole component. So maybe after I have shortlisted some components, I can add all these 4 components to the product tray and drag and drop them here. And now I have all these components in the graph. Further, I can also drag drop the chart reader and find out the inductance value at different for different components at a particular current, and also I can compare the loss model of these 4 components shortlisted. So I can see here the total loss all are nearest to the same ballpark figure, between 64 to 69. So you can select any component that you want that fits your design, fits your size in your circuitry, that fits your inductance value. So now you can select the component. And of course you can use the share option here. You can copy the URL, save it for your future reference, or you can send it to our Würth Electronics colleagues to ask for samples for all these 4 components. You can use this as you like. So let's go to the next question. So how much variety of components can we check in the software? So this is a Würth Electronics tool, so you can check all the listed Würth Electronics catalog products. So if you look at power inductors, as I showed you, we have about 2500 power inductors, more than 40 plus different series of inductors based on the size, based on construction, based on the mounting technique, based on the material. So we have different products. So based on that, you can shortlist the components. So thus this tool gives calculation for selection of protection components such as MOVs, common mode chokes, TVAs, and surge arresters. Of course, recently we have incorporated some tools for MOV, but at present we can see the VI graph of an MOV in our web page, which is very critical for the selection of metal oxide varistors. But soon we will be coming up with some kind of a design tool where you can give your input ranges according to IEC 61004-5 or any other similar standards. You can give your surge voltage, you can give your time period 8 by 20 microseconds and number of repetitive cycles. And if you give all these information, the tool can shortlist MOVs, but at present we are still working on it. As far as common mode choke is concerned, you can directly go to this tool, and we have considered 50 ohms of system impedance for the common mode chokes, and we have already created the attenuation graph for it with respect to frequency. So you can directly go into the common mode choke module and find these components based on the attenuation that you need. So someone has asked for how can we see the core materials details. So of course we only give some basic information about the core materials. If we give too much information, anyone can make the core. So we have a material column in REDEXPERT, which gives you a basic idea which product group this material belongs to. So for example, this component is nickel zinc core material based component. This component has both manganese zinc and nickel zinc. This means many of the shielding materials, many of the shielded inductors will have two cores. One is the primary core inside the winding, other one is the shielding cap on top of it. Maybe in some inductors, Würth Elektronics use two different materials. This means maybe the primary core will be made up of manganese zinc and the shielded core will be made up of the nickel zinc. So in this case we are using both manganese and nickel zinc for making this particular inductor. Of course a lot of data sheets will have this information, and you can of course access the data sheets by this particular column called spec. This is also made easy for a lot of customer. Once you have selected some components, you can go to the spec column, you click on this tab, it opens the datasheet in a PDF. You can also save the datasheet for your future reference. So thank you very much for your participation in this webinar. I have answered some interesting and enough questions. So if you have further questions, you can always address it to our ISIS hotline. You can write emails to us and we will respond it as soon as possible. Thank you very much.